students. Again I came with one more problem. This is also requested by a student. Okay, we'll see that. 10 individuals are chosen at random from a normal population and their heights in inches are found to be 63, 63, 66, 67, 68, 69, 70, 70, 71 and 71 inches. In the light of this data, discuss the suggestions that the mean height of the population is 66 inches. So what they are asking us to find out, they have given different 10 persons they have taken, maybe students or whatever it may be, they have taken and they calculated their inches height. Okay, and they are asking us to find out that on an average all the heights will be 66 inches. They are asking us to find out. Okay, is it true or not, they are asking. Okay, first we'll write what the given values. Okay, so first sample observations they have given. So given that or given data, so n equals to 10 and the sample observations are sample observations. So sample observations are 63, 63, 66, again 67, 68, 69, 70, again 70, 71 and again 71. Okay, so 10 observations they have given. So in order to calculate this one, we are going to use t-test. Why we have to use t-test? Why? Because here see, the sample size is 10 only we are having. Okay, if the sample size is greater than 30, at that time we can use normal distribution, that means z test we can use. But here the sample size is 10, so that's why here we should not use what, z test. We have to use t test in order to test the means. Okay, so null hypothesis we'll write first. Null hypothesis. So null hypothesis, we all know that it is denoted with H naught. Okay, so null hypothesis is denoted with H naught. So what we have to write here, the statement, the mean height of the population, the mean height of the population is 66 inches. So that means what we can write, H naught such that mu equals to 66 inches. Okay, here they told that population mean height. So population mean is denoted with mu. Okay, so next alternative. So we all know that alternative hypothesis controversy for what? Null hypothesis. Okay, in null hypothesis what we have written? So equals to we have taken. So here what we have to take is not equals to, isn't it? Yeah. The mean height of the population, the mean height of the population is not 66 inches, or else you can write not equals to 66 inches. Okay, so that is H1 such that mu not equals to 66 inches. Okay, so and the next is level of significance. Level of significance. So level of significance in the sense what, it is a table value, or we can say that it is a critical value. So as I told you that here we are going to use test, so we have to see the T table, critical region we have to select. So here particularly they did not give any level of significance. So if they did not give any level of significance, at that time we have to use at 5%. So 5% in the sense what? 0.05. Okay. So the critical value or table value we can call the critical value of T, that means T test or T distribution at what? 0.05 level of significance with n minus 1 degrees of freedom. N minus 1 in the sense what? N value is here 10. That means 10 minus 1 degrees of freedom equals to 2.262. Okay, here we have used two-tailed test. Okay, now this is a table value of two-tailed. Two-tailed. How we know that it is two tail, it is one tail, it is right tail, left tail? How we can identify in the sense, if the word comes not equals to, here in alternative hypothesis, the alternative hypothesis itself decides which table value we have to use. So here it comes not equals to. So that means here we have to use two tail. If it is greater than symbol we get in alternative hypothesis, at that time we have to use right tail. If it is less than, at that time we have to use left tail table values. Okay. So, and the next is test statistic. Okay. So, test statistic. So under null hypothesis only we write this formula. Okay, test statistic. So that is nothing but T equals to mod of x bar minus mu by s by root n. That follows T n minus 1 degrees of freedom. Okay, so here they did not give any mean value. So we have to calculate the mean value. How we have to calculate the mean value? Okay, we have to add all these sample observations and we have to divide it with 10. We all know that mean formula. X bar equals to how much? 1 by n summation xi. So that equals to 1 by 10. Okay, summation, in the sense what we have to add all these. 63 plus 63 plus 66 plus 67, 68, 69, 70 plus 70 plus 71 plus 71. Okay. So that equals to what? So we'll add. So 63 plus 66 plus 67 plus 68 plus 69 plus 70 plus again 70 plus 71 plus 71. So that equals to 678. Okay, 678 divided by what? 1 by 10 summation 678 we got. Okay, so that is divided by 10 in the sense 67.8 we will get, isn't it? Yeah. So x bar value is how much? 67.8. Okay. Yeah. And next what we have to find out? We have to find out S. Okay. So in order to substitute here, we have to find out S. Mu value we already know, it is given in the question itself, 66. Okay. So we have to find out now S value. So S equals to, what is the formula? So S equals to 1 by n minus 1 summation xi minus x bar whole square. Okay. So square root of, okay. So s equals to 1 by square root of 1 by, so n in the sense what? 10. 10 minus 1 summation. So I am going to take bracket. So xi values. Xi in the sense what? First one is 63. So 63 minus x bar. So how much we got? 67.8. Okay, similarly I am taking it as 68, or else you can do like this itself. There is nothing wrong in it. Okay, in order to make the calculation simple, I am making this as a round figure. So that is 68 I am taking x bar. Okay, so 63 minus 68 whole square plus again 63 minus 68 whole square plus 66 and the next is 67. Okay, so 66 minus 68 whole square plus 67 minus 68 whole square plus 68, 69. Okay, so 68 minus 68 whole square plus 69 minus 68 whole square plus here 270s, 271s we are having. Okay, so 70 minus 68 whole square plus 70 minus 68 whole square plus 71 minus 68 whole square plus 71 minus 68 whole square. So we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 observations we got. Okay, so s equals to square root of 1 by 9. So how much we'll get this answer, we'll see. Okay, so bracket open, 63 minus 68 whole square plus 63 minus 68 whole square plus 66 minus 68 whole square plus 67 minus 68 whole square plus, so 67 is completed, 68. 68 minus 68 whole square plus 69 minus 68 whole square plus 70 minus 68 whole square plus again 70. 70 minus 68 whole square. So see here we are getting this blink. So if we get this blink, further the values will not be accepted. Okay, so I am pressing here equals to, so how many 70s we have written once, we'll see. So 270s completed, so these both are there. So equals to plus again 71 minus 68 whole square plus 71 minus 68 whole square. So that equals to 82. Okay, so 82 we got. So 82 divided by 9. So that equals to 9.11. Okay, so square root of 9.1111. So square root of 9.1111 equals to nothing but s equals to how much we got now? 3.0185 is the standard deviation value. S in the sense what? Standard deviation. Okay, so now we have to substitute in this formula. Okay, so that is nothing but t equals to x bar. So how much we got x bar? 68 we will take. Why? Because here we have taken 68, no? So that's why here also we have to take 68 itself. Okay, so 68 minus mod of 68 minus mu value, how much they gave? 66. Okay, so 66 by s in the sense what? 3 3 we can write, or else 3.0185 you can write, or else this is similarly equals to 3 we can write. Okay, so 3 by root n. What is root n in the sense? 10. So t equals to, so we'll say 68 minus 66 is nothing but 2 by, so 3 divided by root 10. So that equals to 0.9487. Okay, so 2 divided by 0.9487 equals to how much? Here the answer is once wait ma, 68 minus 66 is 2. So 3 divided by root 10 only, no? Here the formula is, yes, root 10. So 3 divided by root 10, that equals to 0.9487. Okay, so 2 divided by 0.9487. So how much we got? So t equals to 2.1081. Okay, yeah. So now conclusion. So conclusion, here t calculated value equals to how much we got? This is calculated, that means we calculated it. That's why it is called as t calculated. So t calculated equals to 2.1081. T table value, how much we fixed here? At 5%, 2.262. Okay, so 2.262. So now which is greater? Now which is greater? So we can say that this value is greater. So t calculated value is less than t table. So therefore accept H naught. Accept H naught in the sense what? Accept null hypothesis. So what is null hypothesis? The mean height of the population is equals to 66. Okay. So the mean height of the population equals to 66. Okay. So this is about this question. Okay. Yeah. So we'll see one more problem. So that is, see here, the standard deviation of a sample of 15 from a normal population was found to be 7. Examine whether the hypothesis that the standard deviation is more than 7.6 is acceptable. Okay, na? So now what they have given, what we have to find out in the sense, so they have given standard deviation of 15 observations, that is 7, and they are asking us to examine whether the standard deviation is more, we get 7.6. If we fix, is it acceptable or not? They are asking us to find out. Okay, na? So for that, first we will write what are the given values. Okay. So given that n equals to 15, and here sample standard deviation, no? So that's why it is called as S equals to 7. Standard deviation of a sample, no? So that's why it is denoted with 7. And here whether the hypothesis that the standard deviation is more than 7.6 is acceptable. That means this value is nothing but a population standard deviation. Is it correct or not? Population standard deviation will be more than 7.6. Is it correct or not? They are asking us to find out. Okay, na? So sigma equals to what they gave is more than. Okay, we don't write. So sigma is more than 7.6. They are asking us to find out. Okay. So for that we'll write first null hypothesis. So null hypothesis. What is null hypothesis? What we have to take in null hypothesis? So we have to take that standard deviation is more than 7.6 they told no. So first what we'll write here, H naught such that sigma is equals to 7.6 here we'll take. Okay. So in alternative hypothesis what we'll take? Alternative hypothesis is denoted with H1. That is sigma more than in the sense what? Greater than 7.6. That means here we have to use right tail. Okay, as I told you that alternative hypothesis will fix which table value we have to take. So in the before problem, when it comes to equal to symbol, we use the two-tail test. Okay, so now it came here greater than. So it is a greater than symbol, that means we have to use here right tail table value. Okay, yeah. Next, level of significance. Level of significance. So level of significance, we all know that it is denoted with alpha. Okay, so here we are going to use chi-square distribution. So we have to fix the table value of chi-square. Okay, so here particularly they did not mention any level of significance. If they did not fix any level of significance, at the time we have to fix it 5% or else we can call it as a 0.05%. Okay, so the critical value or table value we can say the critical value of chi-square at 0.05 with n minus 1 degrees of freedom, in the sense what n value is 15. So 15 minus 1 degrees of freedom equals to 23.685. This is the table value. Okay, so it is a small sample. Why? Because here 15 is less than 30. So if it is less than 30, it comes under small sample. So when we are going to use small sample, at that time we come across degrees of freedom. Okay, yeah. And the next is test statistic. So test statistic, under null hypothesis we take this formula. So that is nothing but chi-square equals to n minus 1 s square by sigma square. Okay, so this is the formula. Okay, so that follows chi-square n minus 1 degrees of freedom. So chi-square equals to n in the sense what? 15 minus 1. So s in the sense what they gave? 7. Okay, so 7 whole square by, so sigma how much? 7.6. So 7.6 whole square. Okay, that follows chi-square 15 minus 1 degrees of freedom. Okay, chi-square equals to, we'll see what is the value. So 15 minus 1 is nothing but 14 into 7 square. 14 into 7 square. So that equals to 686 divided by 7.6 whole square. That equals to 57.76. Okay, so we'll divide 686 divided by 57.76. That equals to chi-square equals to 11.8767 is the chi-square value. Okay, so now conclusion. Okay, so here chi-square calculated value equals to 11.8767. Chi-square table value, how much we got here? How much we fixed here? 23.685. Okay, so 23.685. So at last, what is the criteria we get? Chi-square calculated less than chi-square table. So therefore accept what? Null hypothesis, that means H naught. So what is H naught? Here standard deviation is equals to 7.6. Okay, it is not more than 7.6. The population variance is equals to 7.6. That is not more than 7.6. Okay. So the population variance equals to 7.6. This is the correct. So it won't be more than 7.6. We have find out. Okay. So this is about this question. Hope you all understand. So keep watching for latest videos. So if you are newly watching, please subscribe to my channel, share with your friends, and don't forget to like and comment. Thank you. Have a nice day.